Hey, this is Mr. Kieran. In this video, we're going to be looking at forces. So forces really make the world go around. They explain so many things. They cause motion. They cause objects to change their shape. But it's really important to understand them. So what I have here, I've got a picture of a skydiver. And the skydiver is doing what? Well, of course, they're falling. So what forces are responsible for that? Well, when you think about it, there's really only one force, and that is gravity. And of course, gravity is going to be acting downwards on the skydiver. So I'm going to use a little symbol here, F for force and G for gravity. So force and gravity is a little shortcut. Then the skydiver did this. He or she opened up their parachute. So what forces are acting on them now? Well, we still have gravity. We always have gravity acting on us. However, why are we not falling as much? Well, the idea here is that we have some air resistance or friction that's acting against us. So it's the air rubbing against the parachute. You can also say it's the tension force from the strings as well. But we're going to focus on the friction force. You notice how I labeled the friction force FR, just as a little shortcut there. And how about this? Oh, I love Bugatti cars. This car, coincidentally, is about the same weight as my minivan. Of course, it's not, my minivan isn't as powerful, but it's the same way, which is kind of a neat coincidence. I'll probably never afford it, but this is a Bugatti Chiron. And this car can accelerate amazingly. It's got amazing handling and just the looks are outstanding, much better than my minivan. Anyway, what forces are acting on this? Well, we're going to have, of course, some kind of gravity acting on this. So we're going to have some kind of gravitational force, but the car isn't falling. What's going on here? Well, it's on a road, so the road is providing some kind of surface force. I don't know what that's called. That's going to put down F question mark for now. But we also know that we've got an engine in here, and the engine is also applying quite a bit of force through the tires on the ground. And I also might have a little bit of air resistance, of course. We have a little bit of friction going backwards. So I'm going to put down FFR there. So you get the idea, there are a lot of forces acting on objects all around us every day. I have another one here, Usain Bolt, and in this case, what's going to happen? Well, which way is he pushing? Let's think about that. He wants to go forward, so in order to go forwards, he's actually going to be pushing backwards, which is a really interesting phenomenon. Why does he go forward? Well, what happens is, this is one of Newton's laws, third law. When he pushes backwards on the ground pushes him forward in the opposite direction. Wow, that's really cool. We'll be looking at that later on when we look at Newton's laws. Okay, well, what is a force? Well, force is really hard to define. So we technically say it's some kind of push or pull that's acting on an object. It could be at a distance force that's not touching the object, or it could be touching. It really depends. But basically, forces can do one of two things. Number one, they can change the object's shape. So they can compress the object, stretch it out, or number two, they can change the object's motion. And that's what we're really interested in this course. They can accelerate the object, so they can change the speed of the object or even change the direction of the object. We already saw that force is a vector quantity. We measure it in newtons, okay? So because it's a vector quantity, we really should have an arrow symbol or a vector symbol on top of the F for force. And we're measuring 35 newtons, and we're always looking for a direction now. It could be up, down, forwards, backwards, north, south, east, west, any direction whatsoever, but we should really have a direction. Okay, so let's look at this example here. I have here a little toy on top of a card, and let's think about the forces that are acting on here. Well, we're going to have, of course, gravity. So we always start with force of gravity acting on it. So I'm going to put a little vector symbol on top here now. Why isn't the toy falling? Well, you got to remember, it's resting on a surface. So when it's resting on a surface, the name for that force is going to be called a normal force. That's the name of a surface force. And the two forces kind of cancel each other out, and that's why this object isn't really going anywhere as a result. Okay, how about this one? What are the forces acting on this wagon? Well, we're going to have a lot if you think about it. We've got some kind of force over here. Oh, it's acting through a rope. So when you're acting through a rope, that's a very special force. We can't just call it a regular force. So I call it a tension force because the rope is under tension. We also have a little bit of a push over here, and the push is acting this way on the wagon, but I'm not going to draw it over here. I'm going to draw it on this side because this is the way the force is acting. It's pulling the wagon this way. We're also going to have some kind of gravity most likely here. Hey, don't forget, we're also on a surface. We've got a normal force, a surface force. And of course, we should all have these little vectors. And we might have some kind of friction here too. So we're going to have a little bit of friction going backwards. And remember, friction is going to be opposing our motion. So let's look at all the different types of forces that we can look at in our course. So the first one's really an applied force. Applied force is just kind of any type of everyday push or pull. If you only have one force, you're going to label it as FAP. If you've got more than one, you might have to number them. Like for F1, this one might be F2, for example. So you might have to number. So what even at F3 if there's a lot of forces that are applied on an object. Tension force is really cool. I like this force. Now, tension forces are very different because you can only do one thing with a rope. You can only pull. You can never push with a rope. And the other neat thing is the force acting on each end is going to be exactly the same. So whatever force is here, it's the same on the other side. You never thought of that, did you? So tension forces are forces, again, strings, exerted by strings, cables, ropes, or chains. Then we've got friction force. Now, friction force we know is going to oppose our motion. And it's really due to the interaction of surfaces that are in contact with each other. It could be the stickiness of the surface, how attracted they are, the roughness of the surface, but it's the interaction of the surface that prevents or hinders motion. And there are two kinds of friction, and we're going to be using these symbols later in the unit, okay? So instead of, we'll just use FR for now, but later we're going to use FK and FS. So FK basically is kinetic friction. This is the motion, the friction that opposes the motion of objects that are already moving. So you might have something like a fridge you're trying to move, and you're pushing it, and it's rolling across, or being dragged across the surface. That's the kinetic friction. And then you might try to move something, I don't know, even heavier, like a freezer full of food. Well, if the freezer doesn't move and you're pushing on it, you have a force going against you. So that would be called the static friction. So static friction is opposing the motion of objects not yet in motion. Okay, we already know gravity. And remember, gravity is acting downwards. A neat thing is this, though. The Earth is attracting the skydiver, while the reverse is true as well. The skydiver is also attracting the Earth with the same amount of force. Why doesn't the Earth move? Must be something because of the size of the Earth. We'll be looking at that later on. Okay, we already saw the normal force. Now remember, the normal force is a surface force, and it's always perpendicular to the surface. Here we go. There's my surface. Which way is the normal force? Perpendicular, 90 degrees, always. So that means that sometimes the normal force isn't upwards like we have over here. What if I have an object that's on a ramp? In that case, what's going to happen is the normal force, or the surface force, is going to go perpendicular to the surface, so it's not exactly upward. So keep that in mind. And the normal force is not always equal to gravity. We'll see some examples in the unit as well. So all of these are summarized in this little table that you have in your workbook. So I'd like you to add all of these little symbols in here, add little annotations here and there. And what we're going to be looking at the next video is, well, how can we keep track of all of these forces? Hint, the diagram on top here is going to help us out. Anyway, that's it, guys. Take care.